ओके डियर स्टूडेंट, आज के वीडियो में टुडे आई वांट टू डिस्कस विथ यू टू कैलकुलेट इलेक्ट्रिक पोटेंशियल ड्यू टू an electric dipole. In the previous video lecture, we have discussed about how we calculate electric potential due to a point charge. Today, and also we have discussed how the electric potential at a point can be calculated because of group of charge. As you know, an electric dipole is a system of two equal magnitude and opposite sign, collection of two charges which are opposite in sign and equal in magnitude, which are very close to each other, and these two equal and opposite charges at a very close distance will form an electric dipole. So as means you can say that dipole is a system of two point charge particle to system of 2 point charge. Okay, and here in the figure we have taken AB, an electric dipole whose electric dipole length is given 2L, and C with the center of electric dipole, and we have taken a point P along its axial point, means along the line joining the A to B. Either we take the point in this side or in this side, doesn't matter. In the figure, point P lies at a distance r from center of the electric dipole, so definitely it's a distance from, this one is the minus q charge and this one is the plus q charge. So the distance of point P from point charge plus q will be r minus L, and from minus q point charge it is r plus L. As we know, the electric potential due to a point charge can be written as equal to 1 upon 4 pi epsilon 0 q upon r. Q be the source charge because of which the potential at any point is V, and r is the distance of point from the point source charge. Here there is no term k involved. It means the point charge and point of observation and point charge are in the free space are here. Here, if we assume that dipole is placed, if the dipole is placed in air and point of observation is also in air, then we have to calculate, first we have to calculate the electric potential at point P due to plus q charge, because we know the point charge, we know the distance of point P from the point charge plus q and minus q. Similarly, we know we calculate the electric potential due to minus q charge because we know the distance of P from minus q, and charge is definitely given minus q. As you know, the potential because of negative charge will be negative, and because of positive charge potential will always be positive. So we have in all at point P we have to calculate the electric potential due to these 2 point charges which form an electric dipole. Okay, let us calculate it. The electric potential due to a point charge plus q at point P. Let this be V1. It is equal to 1 upon 4 pi epsilon 0 q upon r minus L. Let us write this as equation 1. As from this figure, q be the charge placed at B, rather r, here we put r minus L. It is because the distance of point P from plus q charge is r minus L. So the electric potential due to a point charge minus q at point P can be written as, let this be V2 is equal to 1 upon 4 pi epsilon 0 minus q upon r plus L. Okay, let us write this as. Since our electric dipole is a system of combination of 2 point charges which are equal in magnitude and opposite in sign, so now the electric potential at point P due to an electric dipole. When I say due to an electric dipole, it means it is due to minus q charge, potential at P due to minus q charge, and potential at P due to plus q charge both. So let this be V, and this is nothing but V1 plus V2. This is the algebraic sum of the potential due to individual point charges, and if we write it, it comes out to be 1 upon 4 pi epsilon 0 q upon r minus L minus 1 upon 4 pi epsilon 0 q upon r plus L. Why I write here minus? It is because minus q is written here. If we take minus on the left side or here, this becomes rather plus 2 minus 1. Now let us solve this, okay, and we will find that after the solution, this V comes out to be, take 1 upon 4 pi epsilon 0 q outside, so we will have 1 upon r minus L minus 1 upon r plus L, okay, and this will be equal to 1 upon 4 pi epsilon 0 q. If we take LCM, r minus L and r plus L both, here is the r plus L minus r plus L हो जाएगा, and this gives you 1 upon 4 pi epsilon 0 q, r cancel out, 2L upon, and this can be written as r square minus L square. As you know, by the factor a square minus b square can be written as equal to a square minus b square. It's nothing but a plus b and a minus b. So in place of r minus L, r plus L, we write here r square minus L square, and this can be written as equal to 1 upon 4 pi epsilon 0, rather q into 2L, we can write p r square minus L square, okay. So this is the electric potential due to a point charge, rather due to an electric dipole at point P. Here P is the nothing but q into TL, which I have already written in the very beginning of the derivation. P is an electric dipole moment of this given electric dipole. Let us suppose P is the electric dipole moment of this electric dipole, whose magnitude can be written as equal to q into 2L. So if we just take assumption approximation, since r is very large comparison to L, so r square would be very large comparison to L square. So in place of r square minus L square, we can write approximately equal to r square. Now this V can be written as equal to 1 upon 4 pi epsilon 0 P upon R square simply. If we compare this relation of P and R, this expression of electric potential due to dipole with the electric potential due to a point charge, we will find that due to point charge, the potential 1 upon 4 pi epsilon 0 q upon r, and due to dipole it comes out to be 1 upon 4 pi epsilon 0 p upon r square. Here v is proportional to 1 upon, here v is proportional to 1 upon r square. If we compare this electrostatic potential expression for the dipole to the electric field for the dipole, you will find that along the axial point E can be written as 1 upon 4 pi epsilon 0 2p upon r cube. Okay, 2p upon r cube. Here it was E is proportional to 1 upon r cube axial के केस में. Okay, but in case of electric potential की बात करें तो it comes out to be V is proportional to 1 upon r square. ये कंपैरिजन से पता चलता है. इलेक्ट्रिक फील्ड पॉइंट चार्ज के कारण हम लोगों ने देखा था E ड्यू टू पॉइंट प्रोपोर्शनल टू 1 अपॉन r स्क्वायर, पोटेंशियल प्रोपोर्शनल टू 1 अपॉन r आया, और फील्ड डाइपोल के कारण जो थी प्रोपोर्शनल एक्सियल पॉइंट के रिगार्डिंग 1 अपॉन r क्यूब थी, और एक्सियल पॉइंट पर जो पोटेंशियल आया it comes out to be P is proportional to 1 upon r square. So this is the electric potential due to an electric dipole, and similarly we can calculate the electric potential because of an electric dipole in the second case, which is known as transverse case, or you can say it is the it's along equatorial line, along its equatorial line. Okay, equatorial line, or you can say transverse position, Okay, so how we calculate it? Let us draw an electric dipole. Let minus q be the charge here, plus q be the charge here, and as you know, the equatorial line is it is nothing but a line, perpendicular line which is drawn on the perpendicular bisector of this axis of the electric dipole. The point P either taken along upward or downward. This is known as equatorial line. इसको क्या बोलेंगे? इक्वेटोरियल लाइन बोलेंगे, और इसमें जो प्लेन लाई करेगा that is called equatorial plane. And here let us assume P be a point which is at a distance r from the center of the dipole. Let's see be the center. This is at a distance L from center. This is also at a dstance L from center. And now if we draw this, what is the distance of point P from these two charges, we will find that it comes out to be under root r square plus L square. This is also r square plus L square. So you can say that this is the isosceles triangle whose two sides are equal, and this is the perpendicular bisector of this axis. So let us assume AB, we have to write this as in the very beginning. Let us consider an electric dipole of dipole length 2L having electric dipole moment P is equal to Q into 2L. Okay, and P be a point at a distance r from the center of the dipole along its equatorial line. Definitely the point P will lie AP is equal to BP is equal to under root r square plus L square as from Pythagoras theorem. So the potential, electric potential at P due to plus Q charge, let this V1 equal to 1 upon 4 pi epsilon 0 Q upon under root r square plus L square. And now the electric potential at P due to minus Q point charge, let this be V2 1 upon 4 pi epsilon 0 minus 2 upon under root r square plus L square. Okay, as you know, the potential due to negative charge is negative, potential due to positive charge is positive, and as we have done earlier case axial position, since electric dipole is a combination of two point charges, so in order to calculate the potential at P due to whole electric dipole, we must have to calculate the potential at P due to minus Q, potential at P due to plus Q, and take the algebraic sum of both. We will find the electric potential due to net electric dipole. So the electric potential at P due to an electric dipole can be written as V is equal to V1 plus V2, and this is nothing but 1 upon 4 pi epsilon 0 Q upon under root r square plus L square minus 1 upon 4 pi epsilon 0 Q upon r square plus L square under root. So this gives you the 0. So this is the extraordinary result comparison to the axial position. In this result we found that there is no electrostatic potential because of electric dipole along its equatorial line. इस equatorial line के किसी भी point, इस पर कोई भी point लें, if we take any point, we will find that there is no electric potential at this point because this point is at midpoint. So the distance of here is the potential 0, here will be the potential 0, here will be the potential 0. If you draw a plane which is passing through this line or passing through this line, and to point, if we take any point on this plane, then definitely it has got 0 potential. So you can say that if we draw a surface passing through this line, that will be the equipotential surfaces. Now इसका discussion हम equipotential surface का अगले lecture में करेंगे. So we have derived both the expressions, electric potential due to electric dipole in axial position and in equatorial position. We found that V axial due to dipole comes out to be 1 upon 4 pi epsilon 0 P upon r square, and V equatorial it is 0 है. और जब हम E इक्वेटोरियल की ट्रांसवर्स ले रहे थे तो ये क्या मिला हमको 1 upon 4 pi epsilon 0 P upon r cube. तो ये काफ़ी कुछ डिफरेंट रिजल्ट मिल रहा है. Now on the next lecture we will discuss I will discuss with you the electric potential due to an electric dipole, not specific cases but at a general point which is at an angle theta with the axis of electric dipole. Okay, this all about